Hi everybody, welcome to the video. For today, we're gonna summarize what we've seen in the previous videos on how to save and spend in retirement. So let's get going. So what do we know from the previous videos? So we need to plan. It doesn't happen by magic. You can do it yourself in Excel, or you can see a financial planner. Obviously, if you do it yourself, you have to study up, but I can point you towards the right places and the websites to go, and I'll keep publishing the videos. You'll save money, obviously, if you do it yourself. Compounded interest is your friend. We showed that in the second video, Monte Carlo and compound interest. 10% interest is the high watermark goal. There's very few investments that'll get past 10%. Maybe small sized company stocks, they call small cap stocks, can go up to 12%, but the variation is higher. So I like to stick with a nice blended S&P or Wilshire 5,000. So using the last 100 years, we showed this in the last video, to get 10% stocks, we can do that. Regardless of how the years were randomly selected, it always comes out to 10%. It's actually a geometric mean, but because of the compounded interest, we don't have to get into that. But we can get about 10% if we invest our money in stocks and hold it. The best institutions for buying your mutual funds or ETF is Vanguard or another low-cost investment house, because that way you keep more of your own money. It's important to know that stocks have high variation. That's why we showed the Monte Carlo and we randomly selected it, and so it would happen potentially in the future. But we don't have to run Monte Carlo all the time. We can use what's called standard deviation. It's a cool statistic, and it'll help us understand our appetite for risk and help us make sure we never run out of money in retirement. So 401ks and ROAs or pre-tax is the best route because you don't get taxed. If you were making 10% investment return on an after-tax, you might really be making 7 3/4, 8%, because you'd have to give 2% to the government for taxes. A 4% withdrawal rate in retirement nest egg is a reasonable plan, but that means you need a lot of money. So we talked about in the second video, we just made up a goal of 500,000. Now, this isn't going to seem like a lot, but just wait for the next two bullets. 500,000, 4% of that would give you 20,000 per year withdrawal, and the plan's made up to factor in inflation every year, so you could give yourself a cost of living raise similar to what the Social Security gives. And imagine if you and your spouse, you both got 25,000 for a Social Security, and so you could add up the $20,000 and the 50,000, and you'd have 70,000 annual retirement. So how do I achieve a nest egg of 500,000? Well, you have to do the math, but we showed that with $188 a week for 20 years, we'd have a 50% chance of, this is wrong, of saving 500K. And what do I mean a 50% chance? Well, there's a 50% chance you'll have less than 500K. And that's why we have to start using standard deviation. Now, you could do this with the Monte Carlo, but it's just a lot of extra work. I only did the Monte Carlo to show you how the historical data could be randomized in the future. And if we bet on the past 100 years through the Great Depression, World War II, the 2008 financial crisis, saving and loans crisis, we'd be okay. So how do we get higher than 50% probability? How do we get like an 80% probability or a 95% probability or virtually certain? How do we get a 99.9% probability? That means the chances, if the past 100 years are a good indicator, the chances you'd run out of money in the future is 1 in 1,000. So there'd have to be another ice age or something, maybe not that, but there'd have to be a cataclysmic event in order for you to run out of money if you saved to this level. Now, $188 a week will only get you 50% chance, but we're going to talk about how to get this amount of confidence and certainty in your retirement plan. And the way we're going to do that is by using standard deviation. Now, standard deviation is kind of a scary word, but it's really not. It's just a statistic, like average is a statistic. Standard deviation is a statistic, and it can do what Monte Carlo did for us. Now, once we know what certainty level we want, we may need to adjust our weekly deposit. Sorry about that. Just type that in. So it's not going to work. That word just means adjust. Adjust the weekly deposit, and then we're going to blend stocks with uncorrelated investment like bonds, real estate investment trusts, maybe gold, maybe commodities, and we're going to lower the standard deviation, which is the purpose of this video. So let's get right into it. What's standard deviation and why do we care? The standard deviation follows a bell curve. Gosh, I'm all over the place today. So what's cool about the bell curve is that the distribution of what number you're going to get is centers around the average. So you're significantly more likely to have a value here than you are at either tail. So that's why we can use standard deviation to figure out the probability, which is the area under the curve, of saving the amount of money we want and not running out of money in retirement. So, okay, how does standard deviation work? I'm going to go through the math just to give you an example, but you can skip over this part if you don't want to know, because all you got to do in Excel is type in this formula and it'll calculate the standard deviation for you. So really quickly, just to go through the math, we have a list of the last 20 years of S&P 500 returns. Okay, and we want to calculate the standard deviation of this list. So here we have a formula for the standard deviation of the annual return. Now, here's 20 years, and what we do is we calculate the so-called deviation from the average. So we know that the average is 9%. Here we've got 30%, So 9 minus 30 is the deviation, and it's minus 21%. Similarly, for this year, we take the average minus 7%, and 9 minus 7 is 2. And these are the deviations. Now, if we added up the deviations, we'd get a deviation of minus 37%. That's not the standard deviation. So what we have to do is we have to square the deviation. So think back to algebra. When a negative number is multiplied by itself, it's positive. When a positive number is multiplied by itself, it's positive. This one, let's give it a little more decimal points. So we square all of our deviations and then we sum them up. So here's the sum of the squared deviations, okay? Then we take the square root of that, because we got to go backwards from our squared to get to our how big our deviation number is, and we divide it by the number of samples, okay? So like I said, all we have to do is write this formula equals standard deviation in Excel and take the numbers and we'll get the same thing, right? You don't have to go through all this math. But understand that the annual return S&P 500 standard deviation is 19%. And we talked about that in video 2 as well. Okay, so what if you buy and hold for 20 years? Then you don't have a standard deviation that high. You have a standard deviation that's corrected by the so-called central limit theorem by the square root of how many years you saved. So I'm sure you guys know square root. Square root is the number multiplied by itself gives the number you're looking at. So the square root of 4 is 2, because 2 times 2 is 4. The square root of 9 is 3. The square root of 16 is 4. So if you divide a number by 4, you've saved for 16 years. If you've saved for 9 years, you can divide your standard deviation by 3. If you've saved for 4 years, you can divide your standard deviation by 2. That's the beauty of the central limit theorem. So we've saved in this hypothetical example for 20 years. So our standard deviation is divided by the square root of 20, and it comes out to be 4. So we've reduced 19% standard deviation to 4. Now, why is that important? We go back to our bell curve. And we see that for 20 years, it turns out that with $188 a week, we'd have at least 0.4% savings. Oh, that's a mistake. No, that's not a mistake. This is a mistake. 98%. So we'd have 98% certainty of at least sort of breaking even. Now, so we saved $188 a week, and all we'll get back is at the end, we won't have our nest egg. We'll have $188 times 52 weeks in a year times 20 years. So we'll only have $195,000 after 20 years. Low case, 95%. Now, you could talk about the high case, but we really don't care. It'll be significantly over 500,000, but we want to know the low case. So what we want to do is we want to fix our investment. We'll have to go up, and we'll have to use the bonds and the other things of uncorrelated assets to get there. And that's the purpose of the next video. But the purpose of this video is to understand the lower the standard deviation, the better our low value will be based on our tolerance for risk. So we obviously don't want 195,000. We want our 500,000. So what's the probability of at least? So if we want 100% probability of never run out of money, so this is the 1 in 1,000 chance, 99.85%. So you round that up to 100%. So that's the average minus 3 times the standard deviation. So that's the key to the whole video. What's the probability of at least? The average minus a constant times the standard deviation. So if we want 100% certainty, we're going to lose 4% of our investment. That really sucks. So that's why we can't invest all our money in stock. We just showed that we'll have a zero gain or zero loss. We won't run out of money, worst case, if we take the average minus 2 times the standard deviation. It's rounded a little, but so that's 0%. Now, what if we're a little braver? Our tolerance for risk is better. So we set our retirement plan based on 84%. That's 1 sigma. So then we'll make at least 5%. That's not that bad. So if we can live with this, if our tolerance for risk is okay, and we can live with that, we'll be pretty good. And then I don't know that anybody would want to flip a coin, but we don't need standard deviation to know a 50% chance of hitting our goal. By the way, in this case, the mean is 9%, but I just used the last 20 years so I could fit everything on the screen. If I used the last 100 years like we showed before, we'd get an average of 10%. Okay, how do we know that we can use the normal distribution? Well, we can take these values. Let's take all of them. Let's take the whole boat for almost 100 years through the Great Depression and everything, all the way up to last year. And I'm going to put this link in the comments or in the description box, but there's a nice website. I mean, you can do this with fancy software, but you can also do it for free. You copy and paste all your values in the website, and then it runs a fancy statistical analysis, and it's called hypothesis testing. So the hypothesis is I have a normal distribution or I don't. And the way you read this is I have a value of 99.11, and I go down to 100 years, and if my correlation constant is greater than this value, then I say I have high confidence that I'm normal. So the fact that we have normal distributions allows us to use these formulas, and then that helps us calculate our risk tolerance. So hopefully this helps understand standard deviation. Just to close, I'll go back to what we covered in, I think it was the first video, some typical standard deviations. So stocks, the standard deviation, let's just round it up. We'll say 20%. Let's do both. Let's do so we'll do annual return, and we'll do standard deviation. And of course, the longer you save and hold, the lower it will be based on the square root of how many years you hold. So delete that, put that there. And once I figure out how to get my web page up and running, I'm going to put these files up there so you can play around with them if you want. But the annual return of a blend of stocks is about 10%. Standard deviation is about 20%. Now, bonds, which we're going to talk about in a future video of uncorrelated assets, only has a return of 6% per year, but the standard deviation is incredibly lower. So obviously a blend of these is good. Gold has an annual return of 4%, and I think a standard deviation of greater than 30%, so we'll stay away from that, and so on and so on. So that's the purpose. We don't want to be doing Monte Carlo analysis and having to do these random generations of trials and stuff. We can just use a formula. Why? Because it turns out statistically it's normal, and there's very simple formulas to determine your risk tolerance. Probably 100% is too risk averse, but I think we can set it up for a nice 98%, and we can figure out how much do we want to save every week. This video is geared for people in their early 40s, but of course you can just use the formulas and use the method any way you want for how many years you have left. So I hope this helps, and I look forward to your comments and seeing you in future videos. Thank you.